So back talking about the spraying results, the things that we want to keep track of, the height is a function of time. Because it really is a function, we want to be able to see that graphically. Makes most sense to actually plot the height as a function of time, and if you highlight the two columns and choose those, most spreadsheets have a facility that allows you to grab and ask you to make a chart. If you have something that's XY data, whatever the name for this kind of thing is, a scatter plot, those are the kinds of things that make sense for plotting this kind of data. And so this shows a height of a thing falling as a function of time. So in 8 seconds it will have fallen, I don't know, looks like about, 300, almost 300 meters in 8 seconds. If you want to see how parameters work, so if you want to start asking questions using this simulation, you can actually start to just change initial values. Let's say instead of starting at 600 meters, we started at 900 or 890 meters. It changes the graph around, and it turns out it doesn't look any different. It just rescaled everything, because no matter where you start, you fall the same amount in 6 seconds. So that actually kind of makes sense. What if we started moving upwards at 90 meters per second? If we're upwards at 90 meters per second, then its trajectory is up. It increases in height, but less so as time goes on. If you started moving down at 90 meters per second, it actually hits the ground well before it would have if it just started from 600 meters with no initial velocity. So already we started to answer a question. How hard would you need to throw it to get it to whatever? Because this is a completely generic simulation, if I started at 0 meters, and if I want to know, obviously this doesn't make any physical sense because now it's falling underground, but let's say that I wanted to know how hard I need to throw it, what's the initial velocity to get it up to 100 meters, I could just try. Let's see if I started at 10 meters. Oops, wrong one. 0, let's say I start the initial velocity at 10 meters per second up. Now it gets up to, looks like, on the graph, hard to tell, but I can look at this here, it gets up to about 10 meters before it turns around. What if I started at 30 meters per second up? Well, then it actually reaches a height of about 60 some odd meters. And this is the parabolic trajectory that you expect for things that are just thrown under the force of gravity. So it reaches a maximum of height of around 60 meters. And if I try 35, now it's up a little over 80, 37, and now it's approaching 39, and now it gets up to about 100 meters. So if I want to get a ball, throw a brick 100 meters high, I need to throw it with an initial velocity of about 39, maybe 40 meters per second. So I've used a simulation, I've used a model to answer a question numerically. You can do this deterministically, but I wanted to do it in a simulation to show how parameters can be adjusted to answer new questions using something that actually works. So we built this to make predictions about how a brick would fall, and we used it to answer questions about how hard you would need to throw it in order to get it over a wall.